You can't just write the other side down and go, oh, I hope they don't notice I don't know what I'm doing at all, and just say left side equals right side. In fact, that sometimes happens, and it actually costs students more marks. Because the first time you make a major mistake in a proof, you lose a mark. Usually proofs are 3 marks. Then, in order to correct your major mistake, you decide to make a major mistake to correct your major mistake. Right? So you make a mistake and it's not working, so you go, oh, maybe I'll just change it to make it equal, and maybe they won't notice. Oh yeah. Then you make a second major mistake and lose another mark. It's not a good idea. So we're not allowed to just write down the next thing. In fact, what you're only allowed to do is use your definitions, like cosecants 1 over sine, cotangents, cos over sine. You're allowed to use all of those definitions, and you're allowed now to include your Pythagorean identities. Sine squared plus cos squared equals 1. So in this question, I would look at this. I don't have anything squared. So because nothing is squared, I probably would not use any of our new Pythagorean identities. So this looks like one I would say, let's go back to our main strategy. Let's change things to sine and cos. Cotangent would be cos theta over sine theta. Tangent would be sine theta over cos theta. Cosecant is 1 over sine theta, and secant is 1 over cos theta. So you need to know these definitions quick, because you're going to be wanting to change things from sine to cos quickly. Can you see that the right-hand side is a fraction times a fraction? How do you multiply fractions? Multiply the tops, multiply the bottoms. And we have successfully got one single fraction on the right side. On the left side, we don't have a single fraction. So we need to get a single fraction. How do you add fractions? You need a common denominator. So as far as showing your work, here you might multiply top and bottom by cos theta, and here you multiply top and bottom by sine theta. And a very common mistake in proofs is getting lazy and not writing the theta. Okay, and Roham, I already caught Roham doing this lots. Okay, imagine taking one letter out of your name. Does it make a difference? At, are you paying attention? Does that sound weird if I just say at instead of at? Yeah, which would be really kind of weird if I take a letter out of your name. Right? It's like, no, so it's the same thing mathematically. Cos without the theta doesn't mean anything. It really means nothing whatsoever. You're not allowed to separate those things. So it's called an E3 error if you decide to take the theta out. Anyways, we've got a common denominator. My common denominator right now happens to be sine theta cos theta. That's good, because that matches up over there. And on the top, I would have cos times cos, which is cos squared theta, and sine times sine, that's sine squared theta. And we're very close. We've got a single fraction on both sides, but the one side has a 1 on the top, the other side has sine squared plus cos squared. But since that's on our formula sheet, you're allowed to say, that's on my formula sheet, I know that that's equal to 1. So my left side is equal to my right side. I'm done. Okay? Next one. Oh my goodness, it has a cube. This is a great example of where if you changed it to sine and cos, it will work, but it will be very long. So even though changing things to sine theta and cos theta is one of our major strategies, we should always look to see if maybe our new shortcut strategies would make this quicker. So some things to notice in this question. This question has cotangent and cosecant. And on my formulas, there's a formula with cotangent and cosecant. So I might be able to change this equation to have only cotangent or only cosecant. This formula has squareds in it. Do we have squareds anywhere in our equation? Yes, we do, right here. So what I would be allowed to do is where I have that cosecant squared, I could replace it with what it's equal to. And on our formula sheet, cosecant squared theta is equal to cotangent squared theta plus 1. What's really nice is if I do that, do you see that now both of my equations, both sides are only cotangent? This is usually going to bode well for solving this. Okay, well, what can I do to simplify this? I could get rid of the brackets by distributing. You can use all of your math algebra laws that you know all the way through. So cotangent times cotangent squared, that would be cotangent cubed. Cotangent theta plus 1 would be cotangent theta, then I have minus cotangent theta. I hope you see what's going to happen next. These are like terms, aren't they? One cotangent theta minus another cotangent theta. Can you see that they would cancel out? And we would be left with just yes.
The 3 dot QD and box mean?
Okay. The 3 dots is so mathematically shorthand for therefore, which is terribly confusing because there are 3 dots and it's therefore. They should have just went with 4 dots. It would just make so much life easier. So that means therefore. Therefore, the left side equals the right side. And this is fancy math Latin for saying what was asked for has been proven. In shorthand, quod erat demonstratum. Maybe I said it right, maybe I didn't. No idea. Anybody studying Latin? Good. So it doesn't matter. Right? So you'll often see in textbooks that when a proof is done, it's like, yes, I've done what you've asked for. Then the little square box is something that I've always done to end a proof. And you actually see this also in languages. If you look at a magazine, magazines these days have lots of advertisements. So if you wanted to actually read an article in a magazine, you start reading it and it says continued on page 26. Flip through 7 pages of advertisements, read a little bit more, continued on page 31. And some, like, I think Maclean's has a maple leaf and an M when the article ends. They have a symbol to tell you, don't keep looking anymore, it's over. The actual article is over. So you don't have to keep working anymore, the proof is over. And it was in one of my textbooks, they had the QED, and then they put a little square. So I've just kept that all the way through. If you want to add your own little, right, little symbol, I'm done, I'm happy, I got it, whatever, you can. Okay.
Hi there, sorry to interrupt.
Hello.
Hi, after class, can I have Rohan to the office for a quick moment?
You bet.
Thanks.
Quad erat demonstratum.
Oh,
What was asked for, demonstrated
okay.
in Latin, roughly. And I might have spelling errors in here too, but who cares, right? Because I'm not going to test you on your Latin. So it's just a formal way to end a proof. And in this one, by using the cosecant squared and changing it to cotangent squared plus 1, you made it shorter and easier to prove. Okay? Rules. You know how I said this, changing cosecant squared to cotangent squared plus 1, is one step. Distributing this would be another step. And then simplifying these would be another step. This would lose a mark. This would lose a mark if you went from here to here without showing work. And so what's the rule of thumb for showing work? You are allowed to do one mental math thing and not show work. But if you do two mental math things and not show work, then you're going to lose a mark. So how do I go from here to here? I have to distribute. That would be one mental math thing. And then I combine like terms and get rid of them. That would be another mental math thing. So this, I would lose a half a mark here for not showing my work. But sometimes you will get questions. For example, you have a sine squared, and in the next step, you write 1 minus cos squared. That's not this formula. I don't have a formula that says sine squared equals 1 minus cos squared. But can you see that you could do that with one mental math strategy? I could take sine squared plus cos squared equals 1, move the cos squared to the other side in one mental math strategy. This is allowed. If you can do something with one mental math strategy off your formula, you don't have to show the in-between step. Okay?
So, for this question, if I take the cotangent angle out and square cosecant squared and minus 1, and I write
Yes. That is great. Great example. So Young said he noticed he could factor this. He took out a cotangent theta because it was in common and was left, oh, this is a beautiful proof. Cosecant squared theta minus 1. Okay? Can you see how I took that out? Now, can you see that with one mental math strategy, you can get cosecant squared minus 1 in that formula? One mental math strategy, move the 1 over. What would it equal? It would equal cotangent squared theta. And then cotangent times cotangent squared theta, cotangent cube theta. Perfect. This is a great example of using the one mental math strategy rule. Because I can get this to look like this from my formula with one move. Where it gets tricky is sometimes you're going to be tempted to do, okay, this would not be allowed without showing work. This is true, that cotangent squared theta minus cosecant squared theta is equal to minus 1. That is true. But in order to rearrange my formula to look like that, I have to do two things. I have to move the cosecant over, I have to move the 1 over. Two mental math things had to happen. So this would generally be seen as not showing enough work. What could I do instead? I could change my cotangent squared to cosecant squared minus 1 minus cosecant squared, and then these would cancel out and I get minus 1. That would be showing enough work. So those some basic guidelines for proofs, right? And of course, there was a final exam one year. had a question, proof like this. The student wrote, ladies and gentlemen, it is obvious that cotangent cubed equals cotangent times cosecant squared theta minus cotangent theta. No work needs to be shown. QED, left side equals right.
It's a good effort.
It was a good effort. Yeah, but the mark was a 0. That's smart. So you can't, and the other thing is, when a question is a proof question, it will never be a trick question. That's like, prove that this works. It doesn't. No, it will work. So if it's not working for you, you are making a mistake. And it's not like, you know how sometimes in grade 10, they would have said factor, and you spend 5 minutes trying, and then you're like, oh, I can't get it. Look at the back of the book, and it says can't be factored. Rip page on your textbook. Get angry because you spend so much time trying to do something only to find out, haha, it can't be done. Okay? The proofs, when they tell you prove, it will be provable. If it is not, and I've made a mistake, okay, my rule of thumb is, if I make a mistake on your test with a question that doesn't make sense, I give everybody 100% on that question, because it was my fault. So, that's okay? Yeah. So if it says prove, you will be able to prove it. Okay, class is almost done. We are going to, okay,